As a part of first assignment, let's discuss what are the assignments which are given by the course instructor. Okay, the first question is like state whether the following statement is true or false. Mean is a measure of central tendency of data set which is robust against the extreme values of data set. Actually, mean is a measure of central tendency, that is true, but the second sentence, which is like robust against the extreme values of data set, is wrong, because like if you take a data set like 1 3 5 7 9, in this data set, even if I change the extreme values, if it is still uh, if the particular property still remains same, that is called robust. But in this case, if you see if you see the median is 5. So if I change the data, and mean is also 5, mean and median both are 5 in this case. Mean and median both are 5 in this case. But if I change the data set, I keep remaining things same, I will just change the extremum, like one end of the extremum. Now median is same, it is 5, but the mean, if you add, it will come around like 12, 27 divided by 5, so you can calculate. So it will lie between 5 and 7. So mean is changing, but median remains same. So which is robust here? Median is robust, mean is not. Okay, so in second question, x bar is the mean and s is the standard deviation of a data set. X bar plus or minus s covers dash percent of data, the assumption that the data is dash distributed. Okay, here you can see this is like this is a normal distribution. In that 1 sigma, which means the 1 plus or minus s is called sigma, 1 sigma plus or minus s. It covers plus or minus 1 standard deviation covers 67% of the data, and as I told already, it is normally it is in the normal distribution. We are talking in terms of normal distribution. In normal distribution, plus or minus s can cover like 67% of data. Yeah, that is what it means. Yeah, if it is like 2 times the standard deviation, it covers almost 95% of the data. So if you have came across this 5 sigma, 6 sigma, which defines the quality standards, like it will be like 99.9999, so it will be going on. So that much um, accuracy is their production, like they won't have defect in 99, like one in million part will have defects like that they used to define. So 6 sigma means they are having very high accuracy in production without any defects. They are very good quality. In other case, like if it is having low sigma, which means like they have a lot of defects, so we can define them in this way. So coming to the third question, in cumulative frequency plot, the value on the x-axis is corresponding to 50% of frequency. Okay, this is a cumulative frequency plot. In this, we can see 50% of the data in the x-axis represents the median, and this 25% represents a lower quartile, and 70% represents the upper quartile. So in case if there is a question which they ask like what is the quartile range, this is the quartile range. You might have learned it from the box and whiskers plot. This is the quartile range, this is the median. They ask you what is the quartile range, you find the data corresponding to the 70% and data means values corresponding to the uh, time in minutes corresponding to upper quartile range, which is 75%, and time in minutes corresponding to lower quartile range, that is 25%, and we can uh, yeah, we can subtract and find the interquartile range. Okay, so they are asking what is the correlation coefficient of, okay, the correlation coefficient of two data sets can take values ranging between. Okay, here we have to first know the correlative coefficient formula. The correlative coefficient of x and y is defined as is equal to covariance of x and y divided by square root of variance of x into variance of y. Here, as we know, variance of x and variance of y both are positive quantities because they are in the squares. They are always a positive quantity. So the sign of the values depends on the covariance. And if you see in this, so covariance can be negative, also can be positive. So sign is decided by the covariance. Okay, if you see like in this, uh, uh, the lower range is not negative in these two, so these two are not included because it can be negative, right? So it is not, it can be neglected, and now just you have to think about either it's minus 1 by 2 and 1 by 2 or minus 1 to 1. So as we have discussed, the range can go from minus 1 to plus 1 because like the minus 1 represents the linearity, like completely linear in negative, and plus 1 corresponds to completely linear in positive as a positive slope. So the coefficient of can takes ranging from minus 1 to plus 1, and 0 represents there is no correlation. Minus 1 represents they are correlated in negatively correlated, and positive 1 represents they are positively correlated. With increase in x, y also increases, but in case of minus 1, with increase in x, y decreases. This is the negative correlation. Coming to the fifth question, which of the following methods are common measures of central tendency? So common measures of central tendency is measuring the central tendency. For that we have mean, median, and mode. This is a common measure of central tendency. We all know about mean, median, and mode. Mean is the average, median is the central part of the data, mode is the highest frequency of occurrence. So they define the central tendency of a peak. This is positively skewed normal distribution or positively skewed bell curve, and the standard deviation is the average distance of all measured from the mean value. So from the mean, how it is varying, you can see in this, you have a highest person here, tallest person here, and shortest person here, but the average is between them, and the range of distribution and standard deviation is within the given limit. But if you see the range, it is between the shortest one to the tallest one, so the range is always higher than the deviation. Okay, they have asked for a negatively skewed dataset. Which of the following is correct? Okay, for symmetrically distributed one, all are equal. This is for symmetric case. Symmetric case, mode is greater than, okay. Okay, if you see in this, mean is greater than median. So in negatively skewed case, mode is greater than median, then comes mean. So this option can be applicable to that. Okay, the experimental values of diffusivity of silicon and germanium is given in the table below. Calculate the correlation coefficient between the temperature and diffusivity. What can we infer from this value? Okay, so if you plot this temperature and diffusivity, this is not a linear curve. This is like a exponential growth function. So if you define a function for this, this can be fit into an exponential growth function. And okay, coming to the correlation coefficient, first we have to find the covariance of x and y, then we have to find variance of x and variance of y and substitute back in this formula. Then we will get the um, solution for this. From based on the values, if it is 0, then there is no correlation. If it is getting, we are getting negative value, they negatively correlated, and if we are getting positive value, they are positively correlated. If we are getting 1, it is like perfect linear relationship. If you are getting less than 0 to 1, then it is like a kind of a deviation from the linearity. That's what it means. So for that we have the formula of covariance. Covariance of x comma y is equal to summation of x minus x bar y minus y. So here if you for the given data you can easily find x bar. It's nothing but add everything and divided by 4. So we'll get around 625 degrees Celsius is the mean value. Here y bar is nothing but add everything and divided by 4, it is 6.007. Yeah, 6.007 is the y bar. Then n is capital N is 4, n minus 1 is equal to 3. So if you substitute in this, you will get something like for covariance of x and y, it is um, 550 minus 625 into 0.018 minus 6.007 plus 600 minus 625 into 0.31 minus 6.007 plus plus 650 minus 625 into 2 2.7 minus 6.007. Plus 700 minus 625 into 21 minus 6.007. So get all the summation and divide by 3. You will get some value, typically close to 500 or 600. Then you find the variance of x and variance of y. We all know variance of x, variance formula. Variance is nothing but variance is equal to summation of xi minus x bar the whole square divided by n minus 1. So similarly we can find the variance in this way. For variance of y, summation of yi minus y bar divided by n minus 1, sorry, the whole square n minus 1. So we'll get the variance of x value, we'll get some variance of y value, both are positive. Then we have to substitute back in this equation. you will get some correlation coefficient value. So based on that we can give the answer to this. One answer is the relationship between temperature and diffusivity when plotted can be seen not linear but exponential. Yes, and from this answer whether we are getting positive or negative, you have to decide between these two. Diffusivity is independent of it. No, it is not independent of temperature, because we have seen in the plot with increasing temperature the diffusivity is also increasing. So that's a relationship. And if you are a metallurgist, you know the relationship, Arrhenius type of relationship. Okay. So eighth question is okay. It's a descriptive kind of question. Here, if you see, material researchers have developed two types of alloys. This is alloy A, alloy B. It is in pre-publication. They have given the service conditions like alloy A has a range of 600 to 1080 1800 degree 1800 hours of service life. Service life means they have um okay they have been loaded at a particular stress and temperature, both A and B, and one material alloy A lasted alloy A lasted up to 600 hours in the lower limit and up to 1800 hours as an upper limit. You see, and 1200 is a median. Similarly, for service condition of alloy B, if you see 900, it has lasted up to 900 hours as in the lower range and up to a higher range 1500 hours. Okay, so now we have to choose an alloy for our application. So their question is, which alloy would you choose? Uh, it's very intuitive. Like we will go with the less scatter alloy. And since both are having similar median and sorry similar median, yeah. So uh, similar median, so both can be considered. But if you see alloy B, it's more consistent, because if you see the lower quartile, lower range is not exceeding much and much like 600 here it is 600, but here it is 900, and upper range is not a problem, but lower ranges should not exceed. Like if I use my if I use my alloy in service condition, if I expect to have 1200, or like if I as a safety limit I will set the lowest one. Like here I for my lowest is 900, so I can be very confident like it can withstand up to 900 hours without failure. But if I take alloy A, though I have the advantage of like up to 1800 hours, but due to some conditions, like in metallurgical aspect, it can be due to defect. During testing, one would exhibit 1800 hours, and but one would have failed at 600. So this is like very inconsistent. If I consider this alloy, my life is like my lower. I have the higher risk, because I can't rely on the more than 600 hours. 600 hours. I may or may not get the failure too early. So I cannot choose alloy A because the maximum service life is 1800, because I have to consider median and lower limit as well. So alloy A and B have equal preference because mean service life. Okay, this is kind of true, but if considering other situation like lower limits and other things, we need not take this uh, as our preference. So alloy B has spread of data in interquartile ranges less. Yeah, this is interquartile range. The alloy spread is less. So this can be a reason, and we will see the next one. Alloy B, because the lower quartile range is between 900 and 1000 hours, which means that it is less likely to fail before. In my view, this is more apt answer, because like lower quartile range is very less. I mean, it's 900 hours, so it is highly reliable. It's less likely to fail before 900 hours. But here it has high likely to fail before 900 hours. So that is the difference. Okay, this is the probability question. So we have two boxes. So one box contains 8 white balls and 2 black balls. Other one contains 5 white balls and 3 black balls. Okay, the question is one ball is drawn random and kept it in another with another box and okay, another bag and in unseen condition, which means like we don't know what ball we have taken. We are asking what is the probability that the ball drawn from the bag is black. Okay, here we have two conditions. Okay, if I'm going to draw a ball from this, there are two conditions. One is condition A is the transferred black is transferred from the bag. The other condition is white is transferred. Since both will affect the total ball availability in the bag too, we have to consider both the case. So A, if you are considering A, then first we should know what is the probability of A being taken from the bag A. Sorry, what is the probability of black being taken from the, okay, let me make it clear. Okay, what if we are considering uh, case A, probability of occurring of case A. So total probability is of this occurrence, which means like drawing the black ball from the bag B is equal to probability of A plus probability of B. Okay, probability of occurrence of A is, first we have to take the ball from black ball has to be taken from the bag A. For that the probability is 2 by 10 and both are independent even. Then what is the probability of taking again the black ball from the bag B? Okay, already we have transferred one ball, so it is now total balls are 9. So out of which 4 are black balls. So okay, this is the thing. Okay, for so A is done. So B is white is transferred from this. For transferring white, the probability is 8 by 10. Then probability of taking white is 3 by 9. So it is 8 by 90 plus 24 by 90. It's 32 by 90. Or we can simplify as 16 by 45 is the probability. Okay, the probability distribution function of a discrete random variable x, which represents the number of defects in a gas product. So this is the probability mass function because it's a discrete random variable. So where x can take any value between 0 to 3. So they are asking what is the value of constancy. As you all know, summation of the probability is 1, and for x 0 to 3, f of x, here f of x is c into x square plus 1 is equal to 1. So substitute the values. So if I substitute 1, it is c. If I substitute 1, then again it is c into 1 plus 1 is 2c. If I substitute 2, it is 2 square plus 1, 5 is 5c plus 3 square plus square is 9. So it is 10c is equal to 1. So we are just substituting the max values and we are just adding the function. So it will come roughly close to 18c. So c is equal to 1 by 18. So substitute in decimals. The mean of the random variable. Okay, next question. Mean of the random variable x is given by first moment of random variable. This we have discussed. This in course I have discussed. Okay. So in 12th question, let x be the random variable which represents the yield strength of copper. The expected value of the random variable is 200 MPa. Expected value means its mean value is 200 MPa. What is the upper bound? That yield strength will be at least 225 MPa. So E of x they have given is equal to 200 MPa. This is expectation of x. Then yield strength will be at least, what is the okay, they are asking what is the probability of A is 225 MPa. What is the upper bound being 225? So x greater than or equal to 225. The probability of x being greater than or equal to 225 is should be E of x by 225. We already know what is E of x. Nothing like 200 by 225. Okay, this is using Markov's inequality. So the upper bound can be 8 by 9. So this is the answer. So with this we are done with the assignment 1.